Hello, hello, hello. We should be live. We should be live. Good morning. Sorry for the delayed start, but we should be live. I had some issues this morning that I had to manage, but hopefully we are okay now. Good morning, good morning. I'm sending all of the necessary links in a second. Welcome, welcome, welcome. There we go. Good morning, good morning. Good morning. Okay, hopefully this works. Sorry for the delay. Hopefully you guys are out there. We'll begin. Good morning. I hope you are out there. Okay. I'm going to check in a second. Good morning. Good morning. Oh, where is this? Let's see who's out there. Three of you. Good morning. Who's there? Brittany, Sarah, good morning. Sorry for the delayed start. I had to take care of an issue this morning, but as usual, so what is it today? Monday, May 11th. May 11th, Monday. Wow, time is just going so quickly. Oh. So we're in this, what, almost 2 months. We're approaching 2 months. Good morning, Gianni. Crazy. Hopefully everyone had a nice weekend. Let's see what we could put on the board to see if it's working. I'm just trying to think. A good word. Um, I don't know. Let's see. Aha. I'm going to do this. So, good morning. So the board is now operational. I put like a combination of letters and Roman numerals. Let's see if it works. So the board should be live. It should be active. So please click on the board, see if it's working. Anyone. So again, the link should be shared. If you can just look to the board and see if it's operational. Anyone. I hope it's working. All right, so I just need you to click on the link. Again, everything was shared in our classroom. Sorry for the delayed start. I just had to take care of something this morning. I apologize. But if you can please look to the whiteboard, all the links are in our classroom. And yeah, we'll get started once you guys confirm that this is working. Just need one person. If it's not working, please tell me. Can you hear my voice? Yes, FF7. Oh, yes. So I don't know if you know about that. Maybe later on you can Google it. The only reason why I bring it up is because that game was made in 1997 for the PlayStation 1, and they talked for years about remaking it in these more modern consoles. It was supposed to come out in PlayStation 3, and it finally came out on PlayStation 4, maybe like beginning of April, and I started playing it. And I've been playing now for maybe like a week or more, but only like an hour or two at a time. I'm not like binging like 7, 8 hour sessions like some of my friends. But anyway, um, you should look into it. So we're going to continue where we last left off. I'm glad that you are joining me this morning, Monday, May 11th. I hope everything is well with you guys. I hope you had a nice weekend celebrating Mother's Day, that you spent time with your mothers, that you got to do whatever you could given all this craziness, but I just hope it was a positive time above all. Okay, so we're going to look at what we call here Pythagorean identities. I'll share the solutions to the homework. I'm going to throw it in. Good morning, Elizabeth. I'm going to throw it in the, what is it, that part of our classwork section. I'll throw it in the final review sheet portion of the homework section. So let us begin here. Okay, so Pythagorean identity. So it kind of looks bizarre. It looks bizarre at first, and it's saying something like this: for all angles theta for which the function values are defined, the following identities hold. So you're basically told, hey, here's this information, and it's the truth. Please accept it as is. But we don't really like to do that. We like to look at what's happening. Excuse me. We like to look at what's happening. We like to also derive to the best of our ability why these formulas exist. So I believe this is in your notes. It should all be there. But some things to consider. I'll go over at least one of them. I think the most basic one is the first one, sine squared theta. And don't forget, just something to consider now we're in the board, that sine squared theta is the same as sine theta, all of that raised to the power of 2. Just so you know. So sine squared theta is equal to sine theta, that whole thing squared. So just so you don't get confused with the notation. So when we look at that triangle, so we're going to look at the triangle that's given. So we have here 1, x, y. Here's theta. We're looking at the whiteboard. Oop, no, it's drawn differently. Sorry. Let me redraw it. So moving away. Okay, so here we go. Here we have 1, x, y. Here is theta. So what's going to happen is this. But something to consider is the following. So we have this. So 1 is also r, just so you know. If we're in a unit circle, what we're looking at here, so this is also the radius. So just so you know. So just to derive, we could solve for the radius by using this equation. It should be familiar to you, again, Pythagorean theorem. But something to consider that y, so again, notice how I put x squared plus y squared, but remember commutative property of addition, I could do y squared plus x squared equals to 1 squared. And the reason why they have it this way, because if we look at sine theta first, remember sine theta, if we're doing everything with respect to this angle, we have opposite, hypotenuse, Monday morning, opposite, adjacent, and hypotenuse here. So what we're going to do is we could find sine, right? And what's sine theta? Sine theta is really y divided by r, right? But r is 1. So if r is 1, then it's really just sine theta equals to y. So I'm going to get rid of that divided by r. And what's cosine, right? So if we think about cosine theta, so cosine theta, it's going to be equal to x divided by r, but we know that r is 1, so it's x divided by 1, which is just x. So basically what I end up doing is substituting these into here. I'm moving down on the board so that what we have is sine theta, this whole thing squared, plus we have cosine theta, this whole thing squared. All of this is going to equal to 1, but according to the rule, it's really sine squared theta. The notation is the same, plus cosine squared theta equals to 1. So that's one Pythagorean identity. So basically, this trigonometry that has this rule, it's just Pythagorean theorem, but expressed in a trigonometric way. That is the only difference. And again, I believe I have it in the note here. Note that sine x, all of that raised to the power of 2, is the same as sine squared x or sine squared theta. And then we have derivations of that. So if you look at the other two, so if you look at the first example here, if you're dividing, and I'll rewrite it, I'm still on the board, so sine squared theta plus cosine squared theta equals 1. If you divide all of that by cosine squared theta, right? Because we could do that. So basically this here so if we look here, I don't believe we spoke about this. I want to say that we did, but ready? So according to this, what I just blocked off, I'm going to move back up for a second because I think that could be confusing to some. So I'm going to pause here for a second on the board. I'm still here. Hopefully you're following along. I moved the arrow. So if we look at what's given, right, we have 1, this is y, this is x, and there's theta, right? Very poorly drawn, I know. So we know that sine theta is equal to y. We know that cosine theta is equal to x. Now look at what happens when I put sine theta and I divide it by cosine theta. So if we do that, that becomes y divided by x. But y divided by x, if I highlight this, right, this trigonometric function divided by another trigonometric function, it really results in the following. Opposite divided by adjacent. And really what that is tan. So I'm not sure if that's mentioned there, but that's something that you could note, that sine theta divided by cosine theta is really the same thing as tangent theta. So please make sure that you write that. Oh, I actually have it here. Look at this. Wow, I thought about you guys. So it's all in your notes. Very good, I forgot. So if you look there, it's essentially the same thing that I just spoke about. So the only difference is when we go back to the equation, when we were dividing, or that Pythagorean identity, when we were dividing by cosine squared theta, sine squared theta divided by cosine squared theta is the same as tan squared theta. And when we're dividing something with itself, it's just 1. But remember, 1 divided by cosine theta, don't forget that. 1 divided by cosine theta, remember that's secant. But since it's cosine squared theta, it's going to become secant squared theta. I know it's a little bit confusing because now we're dealing with the squares, and now we're looking at a new identity and a new relationship. So if you'd like, I can pause right now so that you process all of this, and then we'll look at an example. So if you have any questions, please let me know. So about another 10 to 15 seconds, and then I'll move forward. So I know it's kind of a lot to process. So let me cue up the next slide. Okay, so going into your classwork now. So let's see what the appropriate handout is. In learning materials, let's see. Not trigonometric functions, not these. Nope, nope. Okay, so if you go to the handout that's labeled trigonometric functions and Pythagorean identities. So you have to go to the handout that says trigonometric functions and Pythagorean identities. It's the second half of it, or if you printed this out, it would be the back page. So let's look. So it's saying here to find sine theta and tan theta, given that cosine theta is equal to radical 3 divided by 4. All right, so there's a couple of ways that we can do this. So we could use the Pythagorean identity. We can. But if you recall the unit circle, so a couple of things here to consider. So this is why it's nice to have options. So if we look here, unit circle, we have the unit circle, and notice that cosine here is negative, right? So don't forget, all students take calculus, right? So a couple of things here to consider. So when we look, right, so cosine is positive, right? So where is cosine positive? Cosine could be positive in quadrant 1 or in quadrant 2, but here it's negative, right? So here we have to figure out exactly where we're going to be. So we could be in either quadrant 2 or 3. But look at this, sine theta is greater than 0, right? So sine must be positive. So no matter what. So if this is the case, then it looks like we're going to be in quadrant 1, or excuse me, quadrant 2. That's what it looks like, especially if cosine theta is negative. So let's debate that it's going to be here for now. And then we could do this. We could set this up. Here we have our theta. And notice here, right? Adjacent. So this is negative radical 3, right? Because cosine theta, if you think about it, adjacent compared to hypotenuse. So the hypotenuse is a length of 4. So what we would need to do is to figure out this length here, which is a y length. You could use Pythagorean theorem if you'd like, and we can do that. And if we do, we'll say that y squared plus negative radical 3 squared equals to 4 squared. So y squared plus, right, just becomes 3. Going to equal to 16. But then y squared equals 13. Y is going to equal to plus or minus radical 13. So take a moment to look at that. So if we redraw the triangle, right? So here's the thing. I'm going to redraw where we're going to be, right? So we have radical 13 here. We have negative radical 3, and then 4. So look at what we have to find. It's saying find sine theta and tan theta. So if this is theta here, we know that we have, sorry, it's kind of messed up here, theta. So with respect to this angle, the opposite side, remember that's sine theta, opposite is radical 13 to the hypotenuse. So we can do that. So we'll have radical 13 divided by 4. Remember, sine has to be greater than 0, so it's going to be positive here. And then we could find tan. we can easily find tan. So then tan theta is just going to be equal to, remember, negative radical 13 over radical 3. The whole thing is negative, right? So opposite to adjacent, but remember we have to rationalize the denominator. We need to rationalize it, so then it becomes the following. Radical, or negative radical 39 over 3. So that becomes tan theta. But what I want you to see, let me see if there's any comments right now. Okay, so far no. But what I want you to see is this. But what I want you to see is how we use the actual identity. So if you forgot, about where, these trigonometric functions are positive, right? All students take calculus. If you remember the identity, right? And what was the identity? If I rewrite it, it was sine squared theta plus cosine squared theta equals to 1. And I believe that we're told that cosine theta is this, right? So I'm just going to substitute this as negative radical 3 over 4 squared. And this equals to 1. All right? So then we're left with this, sine squared theta plus all of this. So we could simplify this. We know it's going to become positive, right? So when we do this, so something to consider, right? So it's going to be this. So sine squared theta, hold on. So here we have sine squared theta plus, this is going to become 3 divided by 16 equals to 1. So when I subtract this, look at what happens. So here we have sine squared theta equals 2, right? 1 minus 3 divided by 16. So what's going to happen is this. 1 minus 3 divided by 16, it's really the same thing as sine squared theta equals to 13 divided by 16. But if you take the square root of both sides, you're left with sine theta will equal to radical 13 over 4. I think we found that. So I know that there was a lot there. So are there any questions right now? I'm sorry for all these notification noises. They are messages, but they're more professional messages. They're not like friends texting me. So I hope you're not thinking that. And I need to have those sounds on, unfortunately. But any questions so far? So look, we did two things, right? We looked at this using sine squared theta plus cosine squared theta equals 1, or the Pythagorean identity. That's what's in front of you right now. We looked at this also using the unit circle. So you have options, right? The likelihood, I can't determine what method you're going to take. It's whichever method you feel comfortable with. I think there are benefits to both. I think by using the unit circle, you start thinking about the signs of the functions more. With the Pythagorean identity, it's definitely an easier or shortcut to finding the values, but then you have to ultimately refer back to the unit circle so that you can think about where this terminal side will end. So again, just some other conclusions that we used, and it's basically confirming everything that we found. So that was example 1. And again, just some caution, be careful to choose the correct sign when square roots are taken. That's why it's, really imperative, or it's recommended, suggested that you sketch it out. If you sketch it out, then you'll be able to see the graph a little bit better. Okay. Okay, so let's move on. So the next one is saying this: find sine theta and cosine theta given that tan theta is equal to 4 divided by 3, and theta is in quadrant 3. So let's look here. So you should get into the habit of sketching, right? So here's x, y. So theta is in quadrant 3, right? So here we have our triangle. Here's theta. So some things to consider, right? And according to this, we have the following. That sine theta, or excuse me, tan theta is 4/3. So don't forget this. Opposite, right, divided by adjacent, right? That's tan theta. So if this is the case, then we could label. But if we're in quadrant 3, this is definitely negative, and this is definitely, I'm sorry about that error here. This board is a little temperamental. So this is -3 for x and -4 for y, which makes sense why tan theta is positive. So what we need to do is the following. Right, so what we want to do is we want to figure out what is what here. So if we look here, we have the following. We have to solve for, I'm going to call it r because it could represent a radius, especially if we were in a unit circle, but we can get into that habit. We'll call this r. So I think you should know by now what this value is. Remember the type of Pythagorean triangle you have. It's a triple, 3, 4, and we're not going to waste too much time today because, again, this is a triangle that we've looked at in the past. So r will equal here to 5, right? So something to consider as well, right? Because we know that sine theta divided by cosine theta is equal to tan theta, right? But we may incorrectly lead this or think this. Because tan theta is 4/3, some of you may think, oh, that must mean that sine is 4, and that must mean that cosine is 3. This is a huge no. This is insanely wrong. So that is not the case. So what we need to do is this. We need to solve for that missing side, which we already did. So I'm just going to sketch it. Here's the terminal side. -4, -3. This is 5. So this is theta. We could use the Pythagorean identity. We can. But if you're comfortable with this, we know all of these values. So what do we have to find? We have to find sine theta. So according to this, remember, opposite, hypotenuse, and adjacent. So sine theta should be -4/5. Cosine theta should be -3/5. So hopefully you found that. But now look at this example. So here, this is what we did basically. So we sketched, again, the coordinate plane. We thought about this in terms of the terminal side. labeling, finding the hypotenuse in this case, having an awareness of uh, the value or the sign of the function that was given, right? In this case, tan, and we were told that it was in quadrant 3, so tan is positive. All students take calculus. So we could easily find the trigonometric values. But if we went about it using the identity, so let's say you're just too lazy for whatever reason to sketch out an entire coordinate plane, you can easily find these values by doing the following. So we could use this identity since tan is already given. Tan squared theta plus 1 equals secant squared theta. We know tan theta is 4/3, so it becomes 4/3 squared plus 1 equals to secant squared theta. So we could rewrite this as 16 over 9 plus, why don't we do 9 divided by 9? That's going to equal to secant squared theta, right? Because that's 1. 9 divided by 9 is 1. Common denominator. So we're ready for this. Then we combine. 25 divided by 9 is equal to secant squared theta. But we take the square root of this and it becomes plus or minus 5/3 is secant squared theta. Sorry, secant theta. I'm sorry for the handwriting here. Let me do this underneath. Writing this underneath, this becomes plus or minus 5/3 equals to secant theta. But what is the secant theta really? That's 1 divided by cosine, right? 1 divided by cosine theta. So if we did the following, the reciprocal, then we have cosine theta. But it must be negative because we are in quadrant 3. So there's a few ways to do this. You can see this here. I know I probably gave you a lot here, a lot to ingest, a lot to process. Oh, I cannot talk right now. Just give me 1 second. Hold on. All right, so any questions? Any questions before we move forward? I know there's a lot happening. Pythagorean identities, the unit circle, the placement of the terminal side. So if you have any questions, please let me know. Alrighty, so typically I would have you answer some questions, but there's just time right now. We don't have a lot of time and I want to move along. So this is what you were supposed to try, and I'll give you the solutions to this. So again, it's basically doing the same exact thing, just some considerations is where you are on the the coordinate plane, and then that will determine the value of the trigonometric functions, whether they're positive or negative. So if you can find the values of these trigonometric ratios, or functions, excuse me, using either the identities or the coordinate plane, you're in good standing in terms of where we are right now in this unit. So I'll give you those solutions now so you can take a look. So I think this is what, 1, 3, 4. I think I have number 2 on a separate sheet of paper, or what I'm going to show you. So take a screenshot, whatever you need to do here, or you can just go back to the video, and then this is the other one, so you can look. So again, even notice here, so there's 2 components. You have the component of the coordinate plane, so you can see that, and then the implementation of the Pythagorean identity. So again, we're going into, let's see, I'm just looking ahead to see how many more sections we have. Yeah, we still have, let me see, 5 point. Right. So we still have about 2 more sections. But at the rate that we're going, we're probably going to, I think, take another week and a half, maybe 2 complete weeks to finish it. And in the meantime, I'm still thinking about the project. The difficulty that I have in sharing the link is that I have to, I believe, add all of your email addresses to it so that you can collaborate. So at some point today, I'll share that link so that we can come up to an agreement as to what a good second project would be. Again, I want you guys to come up with what you think would be an interesting idea, and then we'll work from there. So I definitely don't want to rush the next section. There's just a lot happening, and I'll just preview it quickly because that's where we're going to go tomorrow. And that's going to be evaluating trigonometric functions. So there's a lot here. There's a lot in these chapters, that's for sure, or these sections, excuse me. Okay, so it's about 9:42-ish. Are there any questions before we end today? Any questions, any comments, concerns? There are a few of you in the class today. There are about 9 of you. I have a feeling that as the days go by, it's going to become a little bit more challenging. So there is flexibility with instruction, right? You know, we're still meeting 3 days a week. We're not meeting for that long. However, LaGuardia still requires all of you to show up to class every single day and to check in. So I'm glad that many of you are participating in checking in through the stream, which is great. I'm also replying back to some of you. I'm not sure if you're seeing that. And I look forward to replying back to whatever you mentioned today. But again, we don't have too many more classes left, and attendance is taken into consideration. So yes, there's the high school component that's extremely flexible and understanding, but the college it's a little more strict. So I want you to be, aware of all that stuff. So again, for those who have been regularly attending, I don't think you have anything to worry about. But for those whose attendance has been, spotty, we need to follow up. I'll be definitely reaching out to you so that we can, figure out what's happening. Because I definitely don't want you to lose out on the potential to earn college credit, especially during this time. It's a great opportunity to, make up work, to really do well. And I want all of you to do well because you all have that capability, especially in this environment. So on that note, if you don't have any other questions, I will put the homework up. That homework will be due tomorrow. The homework that was assigned last week, I'll be checking that. Hopefully you completed it. It was review sheet homework for the upcoming final exam. The date is still to be determined. I don't know yet. I'm just trying to figure that out with LaGuardia and with Mr. Randall as well, so that we can all be giving final exams at the same time. So on that note, thank you for your time. I hope you have a great day, and I will see all of you tomorrow morning, and hopefully on time. So again, today something came up at like 8:55, and I had to deal with it, so hopefully that's not the case tomorrow morning. But again, thank you for being flexible, and I'll see you tomorrow. Have a good one.